Hello and thank you for watching my video. Today we will be talking about Chapter 5, Network Address Translation for IPv4. This is part of Semester 4, Connecting Networks, by me, Astrid Krasniqi. Network Address Translation for IPv4. In today's world, IPv4 address space is not big enough to uniquely address all the devices that must be connected to the internet. Network private addresses are described in RFC 1918 and are designed to be used within the organization or site only. So we don't have enough addresses, IPv4 addresses, to uniquely address every device on the internet. So we have a range of addresses available so we can use on the private networks only. Private addresses are not routed by internet routers, while public addresses are not. So we have this private range that we can use it locally only, but as soon as they go to the internet and try to go to the internet, they will not be routed by the internet routers. All the routers on the internet are configured to drop these addresses from this range, so they are available only on the local networks. Network address translation enables private IP networks that use non-registered IP version 4 addresses to connect to the internet. Usually, NAT connects two networks and translates the private inside addresses in the internal network into public outside addresses before packets are forwarded to another network. So you can have a private addresses on your local network that they try to go to the internet, they will be translated before they go to the internet. Otherwise they can't, because the routers on the internet, they will drop them. Now, network address translation, usually that's what we use it for. Translates private network to public network addresses. Not always the case. You can use a network address translation to translate addresses from one private network to different addresses on a different private network. So, for example, for network merges or anything like that. IPv4 private address space. So we have class A. You remember the range? I hope you do. If you reach this stage of the CCNA studies, you should know them. 10.0.0.0 all the way up to 10.255.255.255. This is the easiest. Then we have the B. Class B is the hardest. Okay, class B address range is from 172.16.0.0 all the way up to 172.31.255.255. And then we have a class C address. It's from 192.168.0.0 all the way up to 192.168.255.255. Okay, we have a router here that is connected to the internet or a public network, and it has a public address. Then it's connected to private network, and it has address from this private range. So it's on the range 10.1.1.1. So NAT, what is NAT? NAT is a process used to translate network addresses. NAT primary use is to conserve public IPv4 addresses. NAT is usually implemented at border network devices such as firewalls or routers. And NAT allows the network to use private addresses internally, only translate into public addresses when needed. So devices within the organization can be assigned private address and operate with local unique addresses. When traffic must be sent or received to or from other organization or to the internet, the border router translates the addresses to the public and globally unique addresses. So NAT, for example, here we have a device with IP address 10.1.1.10 with a subnet mask 255.255.255.0, the gateway 10.1.1.1 or that interface. It's trying to communicate with a device here on the internet, for example BBC server, with this address 212.58.246.93. This device is going to create a packet ready, so it's going to be layer 3 source and layer 3 destination. Layer 3 source is going to be itself 10.1.1.10, and layer 3 destination is the BBC server, which is 212.58.246.93. It's going to make this packet ready and it's going to send it to its own gateway, to the router. Now the router is going to take this address, this packet, and is going to change the layer 3 its source address. So it's going to change it from the local address, which was 10.1.1.10, to its own address or unique IPv4 unique global unique address, 95.100.128.170 in this case, and forward it to BBC server. Now BBC server is going to get this packet, but it's not going to know that it's coming from some private network. All he knows is coming from this address here on this router, which is 95.100.128.170. So the BBC is going to reply. It's going to put its own layer 3 source itself, and layer 3 destination is going to be this interface. It's going to forward the packet to the router. The router now is going to change the layer 3 destination from itself to the local or private address, and it forwarded it to the local PC. So that's the steps on the what happens on the network address translation. The terminology for NAT: we have inside network is a set of devices using private addresses. Then we have an outside network, refers to all other networks. So NAT includes 4 types of addresses. We have inside local address, then we have inside global address. That could be the interface address of the router, or it could be some global addresses that we have purchased. Then we have a outside global address and outside local address. To configure Static NAT uses one-to-one mapping of local and global address. These mappings are configured by the network administrators and remain constant. Static NAT is particularly useful when server hosted in the inside network must be accessible from the outside network. For example, web servers, FTP servers, email servers, and so on. So we have an inside local address that's going to be translated to outside global address. It's always on the table. It's constant. Dynamic NAT uses a pool of public addresses and assigns them to first come and first served basis. So when an inside device requests access to the outside network, Dynamic NAT assigns an available public IPv4 address from the pool. Dynamic NAT requires that enough public addresses are available to satisfy the total number of simultaneous user sessions. For example, in this case we have an inside local address 10.1.1.100 that's going to be translated to inside global address 209.165.200.226. The rest of the addresses are available. We have 4 more addresses, 4 are available. So if we have 3 more PCs, all our addresses will be taken. The 5th PC will have to wait till one of the sessions is complete. Port address translation maps multiple private IP addresses to a single public IPv4 address or a few addresses. PAT uses a pair source port and source IP address, so to keep track of what traffic belongs to what internal network. So it uses source port and source IP address. PAT is also known as NAT overload. By also using the port number, PAT forwards the response packet to the correct internal device. The PAT process also validates the incoming packets were requested, thus adding a degree of security to the session. To compare NAT and PAT, NAT translates addresses in one-to-one basis between the private IP addresses and public IPv4 addresses. PAT modifies both the address and the port number. NAT forwards incoming packet to the inside destination by referring to the incoming source IPv4 address provided by the host on the public network. With PAT, there is generally only one or few publicly exposed IPv4 addresses. PAT is able to translate protocols that do not use port numbers, such as ICMP. Each one of these protocols is supported differently by PAT. We have few benefits for NAT, as we saw so far. We have a main benefit: it conserves the legally registered address scheme, increases the flexibility of connection to the public networks, provides consistency for internal network addressing scheme, provides network security. Disadvantages of NAT: will be performance is degraded, end-to-end functionality is degraded, end-to-end IP traceability is lost, and tunneling is more complicated. Initiating TCP connection can be disrupted. To configure a static NAT, there are two basic tasks to perform. First, you need to define which interfaces belong to the inside network and which belong to the outside network. This, you have to remember to do them. It's so easy that you will start forgetting it. First, you define what interface is inside. So, interface FA00, in this case IP NAT inside. It doesn't have to be the first one, but you have to define which one is inside, which one is outside. Then you have to go to the second interface and say IP NAT outside. If you want to map a static map from inside localhost to the outside local address, you have to go to the global configuration command and say IP NAT inside source, and then the source address 10.1.100 in this case, to what interface 95.100.128.170. To verify static NAT translation is always present in the NAT table. So show IP NAT translation, we should see a static NAT already there. 10.1.100 inside local, it will be translated to inside global 95.100.128.170. The static translation during active session, if we say show IP NAT translation while something is happening, we should see outside networks and what protocol is using. To verify static NAT, we can say show IP NAT statistics. Demonstration. On this demonstration, I will configure and test a static NAT. I will use a packet tracer for this demonstration. So I already have router 0 and router 1. They are connected with a serial interface. Router 0 is DCE on serial 000, and the network they are using is 172.16.12.0/24. Dot 1 in this side, dot 2 in this side. Router 1, which is representing the internet in this exercise, is connected to a PC with a crossover cable on this network 192.168.1.0. Dot 1 is fast Ethernet 00, and the PC has dot 100. I have configured the router 1, with a startup configuration and this configuration as well. So interface FA00, IP address 192.168.1.1 with a /24, no shutdown. The interface serial 00, this interface here, with IP address 172.16.12.2 /24, subnet mask, no shutdown. I created a root, IP root 172.30.100.0, 255.255.255.0, and exit interface is serial 0, which is this interface. This route I created because we're gonna purchase this IP address or this range, for example, pretend. So our public IP address would be IP would be on the range of 172.30.100.0 /24. Okay, this is our public IP address. Now I'm going to start configuring. I'll show you the notepad, the startup configuration that I did on router 2. So I copied this. This is a startup configuration. I'll paste it again. It's easy. Right click, paste. That's it. And I have configured this configuration as well for router 1. Done. Okay, I'll do very similar configuration for router 0 or our router. So go to router 0. CLI. This got no configuration whatsoever. I will go to the startup. Just change the host name to R1. Highlight all of this. Right click, copy, paste. All my startup configuration is done. This is there's a mistake there. There's a spelling mistake. So do it again. Yeah, it's fine now. Okay, so we'll go config T, I'll configure this router for this interface first. So this is R0. So it's going to be interface serial 000, because this is a DC, so it's going to be clock rate 64,000, and it's going to be IP address 172.16.121.255.255.255.0, and no shutdown. Now I'll go to interface fast Ethernet 00, IP address 10.1.1.1. No shutdown. Okay, copy all that and paste it to the router. So on the router 1, show IP interface brief. Okay, the interface 000 just came up. If I repeat that command again, both of the interfaces are up. So serial 000 is up and fast Ethernet is up as well. Okay, I will do the configuration for this server. So this server, go to desktop, IP configuration 10.1.1.254/24 subnet, and the gateway is going to be 10.1.1.1. Okay, IP config. Yep, I can see it. All the addresses there. Can I ping the gateway? So ping 10.1.1.1. Yep. So this server can ping the gateway. Now, on this router, I will do like a default static route. Since this is going to be represent my ISP, everything I'm going to send it there. So I'm going to go to the paint again and just do a default static route. IP route all zeros again, and I'm going to send it to 172.16.12.2. Okay. Now do show run. See the configuration. FA00 is fine. Configuration 0000, that's fine as well. And I've got my static route configured there as well. So I should really be able to ping this 192.168.1.100.pc. So ping 192.168.1.100. Yep, that's fine. So there's the communication from the router to the PC. This server is not going to be able to ping the PC, but we don't want it to ping anyway. We want to do the static translation. So if I go to the server and I try to ping the PC, so ping the IP address of the PC 192.168.1.100. This should fail. Yeah, looks like it's not going through. Right. Okay. Now we're going to do translation, a static mapping from this IP address to a public IP address. So we're going to do a static map. So from 10.1.1.254, it's going to be translated to 172.30.100.1. So we're going to translate it to that IP address. Okay, after we do that, then the server will be able to ping the PC. So if I go to the router, and first thing I need to do in the router, I need to decide what interface is inside and what interface is outside. Since this is my inside network, this interface or FA00 will be inside and serial 00 will be outside. So my configuration will be config T interface FA00 IP NAT inside. then interface serial 00 IP NAT outside. Okay, that's complete. Now I'm going to start thinking about the static map. So IP NAT, hit the question mark here. You can see that I need to look for inside source, where I need to find the source. Hit the question mark again. I can get the source from access list, or I can do static. That's what we're going to do. So static, and the question mark again, inside local IP address. So it's going to be 10.1.1.254, where is going to be the destination or inside global IP address. So 172.30.100.1. Okay, that's done. Show run. I'll see the NAT statement is there. IP NAT inside source static. This is the source address, and this is our inside global address. So if I open the notepad, just write that down. What I did in router 0, I went to interface FA00, IP NAT inside, interface all zeros, IP NAT outside. Okay, then I did configuration for NAT. IP NAT inside, source static, and the address is 10.1.1.254, and it's going to 172.30.100.1. Okay, I can copy and paste this. I already done, so don't have to. I'm going to do it anyway. End. Now, show IP NAT translation. Since this is a static NAT, it's constant going to be there. It's always going to be on this list. So inside local address is this. It's going to be translated to this. So now if I ping that PC again, before I couldn't, ping 192.168.1.100, now I can see that I have a reply already. If I repeat the command again, show IP NAT translation, then I can see the 4 ICMP packets have been translated from this source to this source, and this is the outside global address. Okay, go back to the slides. Dynamic NAT operations. The pool of public IP addresses inside global address pool is available to any device on the inside network on the first come first served basis. With dynamic NAT, a single inside address is translated to a single outside address. The pool must be large enough to accommodate all inside devices. A device is unable to communicate to any external network if no addresses are available in the pool. So you have to have, the pool has to be large enough to accommodate all the internal network or internal devices. So the dynamic NAT topology, here we have two PCs on a different network, 192.168.10.10, 192.168.11.10. The router is connected to the internet, serial 010 to the internet with this IP address, and to the internal network with this IP address. So first thing we have to do is define what addresses are inside and what interfaces are inside and what interfaces outside. So interface serial 000 IP NAT inside. Then we go to the interface serial 0/0/0/0. Did I say serial 0/1/0 IP NAT outside. So we defined what this is the inside and this is the outside. Then we create like a access list. Access list 1 permit 192.168.0.0 with a wildcard mask 0.0.255.255 defines which addresses are eligible to be translated. So we create access lists saying, okay, these addresses they should be translated. Then we create the pool, IP NAT pool, then just a name, NAT pool 1 in this case. This is address of the pool 209.165.200.226 up to 209.165.200.240 with a net mask. This defines a pool of public IP addresses under the pool name NAT pool. And then we link those two together. We say IP NAT inside source list 1, so that's going to call for this access list, is going to be translated to this pool. Okay, I will do a demonstration now in configuring and testing a dynamic NAT. I'll go back to the packet tracer. So now I'm going to bring two PCs here. They're going to be connected with the switch. It's going to be a different network. So let me just connect these. This is FA01 and the IP address is 10.200.1.0/24. This one is going to be .1 in the end. So 10.200.1.1. This one is going to have 10.200.1.100. And this PC here is going to have 200 in it. Okay. Configure this PC. Desktop, IP configuration, IP address 255, the subnet mask 255.255.255.0, and the gateway 10.200.1.1. PC2, desktop, IP address 10.200.1.200, and the mask is going to be /24, and the gateway 10.200.1.1. Okay, so I will do the configuration on the router. So this is going to be still router 0. Interface FA01, IP address 10.200.1.1 /24, no shutdown. Copy this to the router. Okay. Now, these PCs are going to be able to ping the gateway, and they will be able to ping the this server here, but they should not be able to ping the client machine on the internet. The reason is because we are not translating anything. We haven't done any NAT. Okay, so we're gonna test the PC1 to ping the gateway, and then to ping the PC on the internet. Go to PC1, IP config. Okay, I can see the gateway. So ping 10.200.1.1, and I got a reply from my gateway. Now I'm going to try and ping the PC on the internet. So ping 192.168.1.100, and it's going to be a request timeout. Okay, so this group of PCs, I want to use a dynamic NAT. The pool, the range on that pool is going to be from 172.30.100.129. Then the pool is going to be up to 172.30.100.134. 6 addresses. That's going to be the pool for these guys. So first thing we have to do is we have to create an access list defining who we want this pool to be for. So first, access list, let's say 15 or 14 here. Access list 14, permit the pool, the network range, so 10.200.1.0 with a wildcard mask 0.0.0.255. So we are saying this range is going to belong to access list 14. Now we create a pool. So IP NAT pool. The pool can be just a name. So my pool, let's say. And then the range, the start. So 172.30.100.129 up to the last address, up to 172.30.100.134. And then you have to follow with the command net mask, and this is going to be 255, 255, 255, 248, the net mask. Okay, so now we have an access list defining the network range. Then we have a pool of our public IP addresses from 134 to 136, from 129 to 136.34. And then we have to like bind these two together. So IP NAT inside source list. So we're going to call access list 1, and it's going to go to pool called my pool. So if I copy all this and paste it, okay, that's complete. Now if I try and test now, it's still not going to work. Okay, I want you to pause a little bit and think why it will not work. It's easy to forget that now we still have to define that interface belongs to IP NAT inside. So we have to go to the interface, FA01 in this case, IP NAT inside. Okay, show IP NAT translation. We can still have the static NAT that we had earlier. We still have. So now when we try and ping from PC1, ping the internet, the PC on the internet, we should have a reply. Or not. Let's see. Okay, here there is a problem, so we should find out what is the problem. Okay, we say access list 14 here, because I have said the IP NAT source list 1, when here I said access list 14, so that's wrong. I have to negate that command. Copy this, paste it, IP NAT inside source list, not 1, 14, because we are binding this access list to this pool. So it's going to be IP NAT inside source list 14, pool, my pool. That's the name. Okay, so yep, that didn't work on the PC1. So if you check, still didn't work. So we go to the router, and we're just going to remove the other statement and add the new statement. Okay, so no IP NAT inside source list 1. We don't have access list 1. We have access list 14. So now we should go to the PC and try and ping it again. Yep, we can ping it right away. So that worked. We can ping from PC2 as well. So try and ping the PC on the internet, pretend internet. Yeah, we have a reply there as well. If I go to the router now and say show IP NAT translation, I should see that I got some translation from PC with 100 ending and from 200 ending as well. They've been translated to this address 129 and then 130 as well. Okay, so that's the dynamic NAT where you create the pool first. Well, create the access list. You define what addresses should be translated. Then you create the access the pool, and then you bind the pool with a list. Configure a NAT overload for a single public IP address. So in this case, again, don't forget you have to go interface serial IP, whatever you have, IP NAT inside. and then IP NAT outside. These are very, very easy to forget, these two, because they are so simple commands, but they play a crucial role. Then access list 1, permit, so we are permitting what our addresses are eligible to be translated. And then IP NAT inside source list 1, so in this we call this access list, and then we say to what interface and overload. So the interface, the global inside global address will be overloaded. Okay, on this demonstration I will show you how to configure and test dynamic NAT with overload to a single IP address. So I go to the packet tracer. Some of the configuration I will have to remove so they don't interfere with the other ones. So again, I'll type here no, get rid of that. No here again, no. Okay. I'm just gonna copy that. Paste it there. Okay. Do show run. So see that it's not there anymore. The static is fine, they can stay there. Okay. IP NAT outside here is fine. IP NAT inside for fast Ethernet is fine. Okay, so to do the dynamic overload with a single public IP address, again, this is going to be router 0. So we have to define access list. So access list, for example, 20 in this case, permit 10.200.1.0 00255. So we created the access list to define who should be translated. Then we create a pool, IP NAT pool, my pool 1, let's say, and then the startup IP address, so 172.30.100.200, and the last IP address should be the same. So 172, only one single public IP address, .30.100.200 net mask /32. Okay, so we create a pool with only single IP address. Then we say IP NAT inside source list 20, source list 20, and it's going to my pool to overload. Okay, I'll copy these commands to the PC. Before I copy, let me just test that the PC1 cannot ping the internet PC. Yep, can't ping it anymore because we removed the previous NAT. So if I paste this, access this 20, permit the range of our internal network, we create a pool with a single IP address, and we bind those two together. Source list 20, and it's going to this pool, my pool 2. No, it should be my pool 1. Go here. Okay. Let's see if it pings. Yep, we have a reply right away. And this one can as well. Okay, that's the dynamic NAT with overload. And we will see PAT with a single IP address. So overload with a single IP address. Where did it go? Here, IP NAT inside source list 1, interface 0. We are overloading to a single interface. So instead of creating a pool now, we just made like access list, what we are eligible, what addresses are eligible, and then we are going to translate to a single IP address. So if I go to the packet tracer, first let me remove the commands that I made earlier. So I'll say here no access list, no IP NAT. That's it. Okay. Alright. Now access list, say 50 this time, 40, permit 10.200.1.0, and then we say IP NAT inside source list 1, and this is not going to go to any other pool, it's going to go straight to the interface. So interface all 0 serial 0/0/0/0 overload. Okay, got a mistake there. So interface, and then what interface? S000, and then the last command is overload here. So we overload. Right. Now this command that we have here, these two commands, pretty much you will have it on any home routers or any home routers that you see. Here will be an access list permitting everything, and then it's translating from inside source list whatever we have to the overload. Again, this list you have to make sure that it's exactly the same. Access list 40, source list 40. Okay. Port forwarding. Port forwarding is the act of forwarding a network port from one network to another. A packet sent to a public IP address and a port of a router can be forwarded to a private IP address and a port inside the network. Port forwarding is useful or helpful in situations where servers have private addresses not reachable from the outside networks. So in this case, we have a web server, an insider network that is going to be reached from outside networks. So we can have anyone that types an IP address of NAT with this port number, it will be forwarded to correct web server. NAT for IPv6. Address space is not an issue with IPv6. IPv6 makes IPv4 public-private NAT unnecessary by design. In IPv6, NAT is used to provide transparent communication between IPv6 and IPv4. NAT 64 is not recommended. Okay, thank you very much for being with me. Hopefully you will watch the next videos. Bye.